Welcome to another fantastic video on multivariable calculus. Today we're going to focus a bit more on three space. Did a couple problems on three space last time. We're going to focus a lot more here. We're going to focus mostly on rectangular coordinates. I know that we will get to vector stuff in just a bit, but for this box right here, focuses on rectangular coordinates. So we can find the distance between 2 points in three space by using this formula right here, which should look pretty familiar to you. It's the distance formula for two space. Just be tack on is the z-coordinate. So we'll talk about the z-coordinates in just a bit here. Equation of a sphere looks like this right here. It's x squared plus y squared plus z squared plus ax plus by plus cz plus d, where a, b, c, and d are constants. And if we're centered at the center of a sphere, we're going to have x naught, y naught, z naught be the center. So there's just two different ways for the equation of a sphere. And we'll kind of talk about that as we get going. One thing I do want to take note of, for a sphere, all of the scalar numbers, constant numbers rather, are the same before x squared, y squared, and z squared. That's why it's a sphere. So first thing I want to kind of talk about before I get to this example is going to be this plotting of points here. So this is what our three space grid looks like. So x goes out in this direction right here. So and then y goes out there, and then z goes up. Which when I first learned this, I was like, wait, why is y not up? My entire life, y has been up, but now it's not. So if we ever talk about the xy plane, that's just what we're used to. Essentially, we'd just take the camera and we would just resurface it back there, so we're just focusing on x and y. But now we can talk about the xz plane, where we just have x's and z's. We now talk about the yz plane. So those are all coming into play here. So I just want to quickly plot for you these points, A and B, and we're going to find the distance between them. So it's going to be a little different for us. So x comes out, y is pretty much to the right, which is different, and then z is up. Like I totally, when I first learned this, was thinking different. I'm sure you think the same as me. I thought that x should be this way, y should be this way, and let's just have z come out this way. But this is pretty standard, so get used to it. How do you like that? Just get used to it. You're fine. So go ahead and plot our points here. I'm going to make little tick marks for point A. So for A here, we're going to go 1 in the x direction, so 1 in that direction. We're going to go 3 in the y direction, 1, 2, 3. And then we're going to go down 2 in the z direction. So z, I'm going to continue that one a little bit. So we're going to go down 1, 2. So if I were to combine all that stuff together here, I'm going to make this purple. So go out here, then here, right, 3 units, and then down 2, something like that. Okay, so here's A. Use your imagination, folks. Come on. And then I'll make blue B here. We're going to go out to 2 in the x direction, and then we're going to go 1 left in the y direction, and then we're going to go down 3. So here, left 1, 1, 2, 3. I'll make this blue. And yeah, that's going to be B. All right, so they're just kind of chilling in space right there. I do want to find the distance between them. I can do that in ink. So the distance between them is going to be the difference between 1 minus 2, sorry, so let's do this. We'll do 2 minus 1 all squared plus negative 1 minus 3 all squared plus negative 3 minus negative 2 all squared. Okay, so that's going to give me, what, 1 squared plus negative 4 squared plus 1 squared again, negative 1 squared, which is going to give us root 18. So I got root 18, which is the same thing as 3 root 2. Okay, so that's the distance between B and A. Yeah, a little different to sketch this stuff. So go ahead and find the center and the radius of this sphere. This is going to be a lot of completing the square. So hopefully your pre-calculus teacher went over the complete the square stuff. I know there's very little completing the square in calculus, AB or BC, especially AB. Very little. I think there's some with like arc, with integrating arc tangent, arc sine, stuff like that. But for the most part, it wasn't really commonplace. So kind of stick with me here, because you're you're watching the video, you probably should stick with me. I'm going to reorganize all this. I'm going to put all my x's together. So I'm going to go x squared plus 2x plus, put a blank right there for the next part to complete the squared. Put all my y's together, plus y squared plus 4y plus double blank, that's a different blank size, plus z squared minus 2z plus one more blank right there. I'm going to go with triple blank. And then actually I'm going to add 10 to both sides here. So I got 10 on this side. So I'm starting to make this look like this equation right over here. So I can find the center and the radius. Because of this standard form of a sphere, I can't say much. But once I rewrite it as this down here, as you can see that bottom part of the box, I'm going to be good to go. So I'm going to complete the square in all of these. So complete the square means we're going to set this up so that it's in x squared plus bx plus whatever, c form. You're going to take half of the b term and square it to figure out what that missing value is. So take half of 2, which is 1, square it, which is 1. So if I add 1 there, I'm going to have to add 1 on that side as well in order to balance this out. And then for this next blank over here, double blank, I'm going to take half of 4, which is 2, square it, which is 4. And I'm going to add 4 to this side as well. I'm going to take half of negative 1 here for this triple blank and square it. It's going to give me just a positive 1, so I'm going to add 1 again. So if I were to complete the square here, x squared plus 2x plus 1 rewrites as x plus 1 all squared. Next one's going to be y plus 2 all squared. And then z minus 1 all squared. This is just factoring. I do go kind of fast at this. I'm just used to, I mean, I've been completing the square since, I was barely walking. So just used to it. Back in before AP, advanced pre-calculus, we did a lot of completing the square stuff. I think that's kind of gone away. So hopefully you're fine at this. All you're going to do is organize your x's, your y's, and your z's, put them in one parentheses each, and then complete the square that way by taking half the b term and squaring it. And you add what I add on one side, you add to the other. So just take some practice. But with this information right here, we are centered, or the sphere rather, is centered at -1, -2, 1. This has a radius of 4, because that's 16 is r squared. So if you wanted to sketch this, just to kind of see what the heck this thing even looks like. -1 is going to be in this direction. So -1 and then -2 that direction. And then 1 in the z direction. So something like this. It's going out 4. It looks something like this. Something like that. I do want to show you Desmos 3D. All I do is I just Google Desmos 3D, and then this pops up, and then you can do everything in 3D here. I just typed in the equation that we had, and then I just kind of rearrange this so that z-axis is pointing up. This is what we're going to be having to be used to. X is coming out this way, and y is coming out this way, and you can see that that's that sphere right there. Just kind of as you're playing around with things a little bit here. If we were to go up here, you can default this to XY, so you can see what this looks like just in the XY plane. If default orientation actually defaults it here, which is not what we do for our textbook, so I just move it back over here. But Plot 3D is another one I will use, but I also use Desmos 3D, so you can kind of see what's going on here. I wish this was a little bit like, see-through. Yeah, that's not the big word for it, but I wish you can kind of see through this a bit. That way you can see what's going on, but you can see where the center is. Actually, maybe I can even just plot the center for you. -1, -2, 1. You can see that point. So it's right there. It's just kind of just chilling. If I move this around, you can see it's, -x, -y, and then positive z. So just showing some things. Okay, for our next example, for like 3-dimensional stuff that we can do, we're going to go back to vectors a little bit here. We're going to have a professional video camera weighing 9 pounds is supported by a tripod as shown to the right. Represent the force exerted on each leg of the tripod as a vector. So for this problem right here, I'm going to first represent each leg as a vector. And then I'll represent the force. The force is going to deal with the 9 pounds. So the game plan here is let's find each vector here And then once we find each vector right there, a couple different things I can do here. I could find the unit vector of each one. I'm not going to do that though. I think that gets a little complicated. I'm going to represent all vectors combined together, supporting the 9 pounds. So let's go ahead and do that. Let's go ahead and find each individual vector. So for the first one, I'm going to do PQ1. I'll call this F1 right here so you can see that. I'm going to do final minus initial, so I'm going to do 0 minus 0, negative 1 minus 0, and 0 minus 4. So for F1, which is going to be PQ1, that is the vector 0 minus 0, negative 1 minus 0, and 0 minus 4, so negative 4. And then for F2, let's go ahead and do PQ2. I'm going to label that for you so you can see where that is. That's going to be right here is F2. So again, final minus initial here. If you notice, we have these square root values right here. That's just because we're trying to match this all around the origin. So they already did all that heavy lifting for us, but we're going to get root 3 over 2, comma, 1 half minus 0, 1 half, negative 4. And then F3 is going to be PQ3. And that's going to be this last one over here. I'll label this as F3 for us. And that's going to be negative root 3 over 2 minus 0, 1 half minus 0, and then 0 minus 4. So if you notice, all of these forces all have a negative 4. So what we're going to do here is we know that the total force is going to be 0, 0, negative 9. Because this camera is weighing 9 pounds, it's going to go 9 pounds. If you know how gravity works, it just goes in the downward direction. So we're just going to go downward right there. Okay. And again, that's just how everything is placed on our XYZ axis right here. So now our force, it's safe to assume, since these are all going to be the same length, that the force is going to be the same in every single leg. So we can write that the total force here, which is just F, not just F1 or F2. So the total force here is going to be the same thing on each one of these. Okay, and this is all because all 3 legs have the same length. All right, they all have length 1, and I can just do that in my head real quick. You can tell that every leg here has length 1. Okay, 0 squared plus negative 1 squared plus 0 squared is 1. Square root of 1 is 1. This would give you, when you square each component here, you would get 3 fourths plus 1 fourth plus 0 gives you 1, so on and so forth. So what we're going to do here is we're going to rewrite this total force right here and rewrite this all out as here. So we're going to have total force here, which is 0, 0, negative 9. And I'm going to take a k and multiply it through everything. So that's going to equal k times 0 for the first force up here is 1, negative k, negative 4k. And then I'm going to get plus k root 3 over 2, k over 2, negative 4k. Plus, I'm adding my third one in now, negative k root 3 over 2, k over 2, negative 4k. Now, I'm going to just pick one of the components, just the negative 9. I mean, you could do each one here to figure them out. But since negative 9 is my value I have, I'm going to just use the negative 9. So negative 9 is equal to negative 4k minus 4k minus 4k. And so you're going to get k to equal 3 ninths here. So whenever we get a negative 9 equals negative 12k, k is 3 fourths. You could have did that for any of these. You could have did 0 plus this k value plus that k value. It should equal 0. But the problem is those are just like cancel out, so that doesn't help us. Same thing on the middle component there, the y direction component. So we have to use the last component. So once I know what the k value is, I can rewrite every force now. So actually I'm going to do that up here in red. So now we know that F1 is equal to 0, negative 3 fourths, and negative 3. Just multiplying each of these by 3/4. We're going to get 3√3/8, 3/8, -3. And then F3 is going to give me -3√3/8, 3/8, and -3. So those are my force vectors for each leg of the tripod. And that's going to wrap up our video here. Like and subscribe for more content.